Hi friends, in daily routine life we observe number of vehicles equipped with diesel engines, and all the diesel engines are equipped with the fuel injection system as a part of the fuel supply system. I have already explained the working principle of the fuel injection system in one of my previous video, so if you like it you can visit. The link for the same has been given into the description, so you can click to visit that video. Engine has to face lots of variable running condition while vehicle is in motion. For example, you can consider variable loading condition, variable weather condition, variable road condition, etc. And each time the fuel supply system, or ultimately the fuel injection system, has to understand the demands of the engine, and accordingly it has to supply the fuel to the cylinders. So friends, in this video I am going to show you the 5 most important points for any fuel injection system that one should keep in mind while designing fuel injection system for any particular vehicle. So let's check it out. So here are the 5 most important points that one should keep in mind during designing of any fuel injection system, or you can say the ideal injection system. So first you can consider the atomization, then you can say penetration, dispersion, turbulence, and injection timing. These 5 parameters, they are most important parameters which are affecting the engine efficiency and the combustion behavior while engine is in running condition. So in this video we are going to see each one step by step. The first one is atomization. Atomization you can define as it is the process of breaking up the fuel droplets into the fine particles. Why we need to achieve a better atomization? Because fine fuel particles have a larger surface area, and higher the surface area we are getting the better rate of heat transfer from the air particles to the fuel particles, and the evaporation will be faster. This is the reason why we are considering the atomization as one of the most important factor while designing a fuel injection system. Now this atomization process, it depends on few parameters like rate of injection, injection pressure, air density, nozzle diameter, and swirl provided to air. Rate of injection you can consider in a 2 manner: the fuel injected inside the cylinder per time, or you can consider as the fuel injected inside the cylinder per angle of crank rotation. Each and every parameters listed here, rate of injection, injection pressure, air density, nozzle diameter, swirl provided to air, these all parameters directly affects the atomization process. Higher the injection pressure, we are getting better atomization. If we are considering the higher air density inside the combustion chamber, then we are getting less atomization due to the attenuation provided by the air particles inside the cylinder. The next one is penetration. From this figure you can understand the word penetration. Penetration we can consider as the distance covered by the fuel particles from the tip of the nozzle to the maximum distance covered by the fuel particles inside the cylinder. Better the penetration, the fuel particle will travel more inside the cylinder, and it will create a better air fuel mixture, or you can consider the homogeneous mixture that will be most beneficial for the efficiency of any engine. This penetration, it depends on the jet velocity, nozzle size, air density, fuel viscosity, and injection pressure. For example, if we are considering the jet velocity, higher the jet velocity, the fuel particle will be able to travel more inside the cylinder, so the penetration will be higher. Nozzle size, if the nozzle size it will be higher, the velocity ultimately it will be less, so the penetration will be reduced. if the air density inside the cylinder will be higher, the penetration will be low, because the air particles, they are dense and they provide the resistance. Likewise, the fuel viscosity and injection pressure will affect the penetration. Dispersion process you can define as the making of a mixture of air and fuel inside this cylinder. Now, better the dispersion, we are able to achieve the homogeneous mixture, you can say. With the help of better dispersion, the combustion process will be smoother and efficiency of engine will be quite higher. This dispersion, it depends on the nozzle design, nozzle cone and turbulence. Now, nozzle design, here you can consider the different types of nozzle available in the market. You can consider the Pintle design, Pintox design with the auxiliary valve. Then you can consider the differential design for the nozzle, etc. And in each and every case, the dispersion we are achieving, it will be quite different. The second parameter here we considered is the nozzle cone. You can observe the nozzle cone in this figure. It is the cone generated once the fuel is sprayed from the tip of the nozzle. Larger the nozzle cone, we are getting better dispersion, but if the cone size is larger, we are getting less penetration. So again, at this point, we need to compromise this both parameter, or you can say we have to find the optimum point where we are getting the better dispersion and the better penetration. Turbulence, you can consider a swirl produced inside the cylinder while air and fuel is getting mixed. So better the turbulence, we can consider the better dispersion. If turbulence is less, then dispersion will be less. Now, turbulence we can create by different design of different components. Like you can choose a different design of the combustion chamber, you can choose different design of the crown of the piston, or you can choose a position of a nozzle tip inside the cylinder to produce the turbulence. These are three factors by which we can produce the turbulence inside the cylinder. Turbulence, as I said, you can consider the swirl produced inside the cylinder while air is getting mixed with the fuel. Better the turbulence will provide number of benefits which are listed over here. So it provides better evaporation. As I said, better turbulence provides better dispersion, and if the air and fuel particles are mixed in a better manner, then the heat transfer rate in between these two particles will be quite faster, and this is the reason why we are getting the better evaporation. Lowers the fuel consumption. Obviously, if we are getting the homogeneous mixture, we are able to achieve the complete combustion, and we can get the maximum power from the fuel supplied. So it will reduce the fuel consumption. Better turbulence, it increases the engine power, as I said, and for the reference we can consider. For the reference, we can say the turbulence increases mean effective pressure by 17%. Now, mean effective pressure, it ultimately indicates the work done by the engine. So higher the work done, we can say we have a better efficiency from the engine. So we can consider indirectly the efficiency of the engine by this term. And turbulence lowers the fuel consumption by 15%. This will be a quite good numbers for any CI engines. Injection timing. Now, injection timing, we can consider the time at which the fuel is injected inside the cylinder, and it will be always measured as a angle of rotation of the crankshaft. It will be indicated by theta. Theta, it indicates the angle of rotation of the crankshaft. Now, Considering the different running condition of the engine, like different road condition, different loading condition, each and every time engine demands the amount of fuel and time to achieve the complete combustion, it will be different. So the injection timing, or the mechanism for the injection timing, must consider these factors and supplies the fuel inside the cylinder at correct time. So here are some factors which are affecting the injection timing, like angle of advance. Now, as I said, injection timing is measured as an angle of rotation of the crankshaft. So here, angle of advance, that means the fuel is injected slightly before the angle prescribed by the manufacturer, slightly earlier, in simple manner. Now, fuel properties, they are affecting the injection timing. For example, you can consider the viscosities to understand this in a simple manner. Higher the viscosity, we required higher time to achieve the complete combustion. So considering higher fuel viscosity, so angle of advance will be higher in this case. Likewise, the method of injection also affects the injection timing and behavior of the engine. Engine running condition, as I said, the vehicles are continuously facing the different kinds of conditions, like variable road condition, variable loading condition, variable weather condition. Accordingly, at each and every time, engine demands fuel. So engine running condition will directly affect the engine timing. And combustion chamber design, as I said in the previous slide, combustion chamber design will affect the overall combustion behavior of the engine. So here are a few designs. You can consider they are common designs which are available in the market. So here is the L shape, T shape, I head, P head. These are the name which is given by the shape of the combustion chamber at the top. So this combustion chamber design, it will directly affect the injection timing. So this is what about the 5 most important factors which are affecting the design of any fuel injection system. Any engineer must keep in mind these points while designing a fuel injection system for any particular vehicles. Thank you so much. If you like this video, don't forget to subscribe my channel and share with your friends so they will get benefited. Thank you so much.